My name is Pauls. I'm from MikroTik support, and in this presentation I will give you the basic knowledge what you should know if you want to configure your router from the zero. For example, if you want to use your router for home and use default configuration, you don't need to worry about anything. All will be done in the default router's configuration settings. So this is only just for those who want to make some advanced setups and configure the router. So first you need to know that the router's system is exactly the same on all router board hardware devices. And this means that you can use the smallest router board devices to use the same features, to learn some advanced things like firewalls, bandwidth management, routing protocols, and so on. Everything is the same. So when you start to configure your router, first you need to access it, and this can be done in 4 ways. You can use a command line interface, which basically is like a terminal where all the commands are done by the keyboard. We have also the webvig version, which is a configuration using the browser. You can use TikUp, which is an application for mobile devices. And the oldest and main application is called Winbox. So this can be used in all the PC operating systems. So this is the view of Quickset. Quickset is for fast configuration. There's everything, most important features is listed in the same window. So if you need to do some really quick configuration changes, you can open the Quickset window, and this is available from the Winbox and also from the web browser, the webvig. So let's start with very simple security things that you should know. So first of all, the routers comes with the default user credentials. The username is admin without password, and first thing what you should do is just change those, because somebody can simply try to log into your router with those default credentials. So this is the first thing you should do. Also very important is to change the wireless password, so nobody can connect to your wireless network and do some destructive things. And this also can be done with simple clicks. You can specify the authentication types and just add the shard key. So this can be done with two steps. Also, good practice is to disable unused interface. For example, if you have placed your router in some public place and you know that you won't use some of the interfaces, then by disabling them, you can be 100% sure that nobody can physically come, plug the Ethernet into these interfaces and just start accessing the router or some other network. So this is the first thing, and the same goes for packages. If you, for example, if you have the IPv6 package, this means your RouterOS is operating in IPv6 mode also, and you should also know the IPv6 firewall. If you don't, then again somebody can access your local area network or the router itself. So if you know that you won't use IPv6, just disable this package, and you will be your router will be secured. The RouterOS also provides some basic services, which is like the ways how you can connect to your router. Again, if you know that you won't use SSH protocol or Telnet, you can simply disable those services, and again you will be 100% sure that nobody will be able to access your router using these services. The RouterOS also provides access using not only layer 3 level but also layer 2. This means that even if you don't have any IP addresses on your router, still you can connect to your router using the MAC address. And this can be done in two ways. You can use the MAC telnet, which is also the terminal access way, and you can use the Winbox and just specify the MAC address of your router. So this is very good how you can connect if you start using the RouterOS from zero without any configuration. But if this is available from the public interface, somebody can again try to get inside your router. So what you have to do, you have to add those interfaces from the LAN side and disable any other interfaces that goes to the public network. RouterOS also supports neighbor discovery feature, which can really help you to debug and to find other devices on your network. But this will also send some neighbor packets through all listed interfaces. So this neighbor packet, which is being sent from the RouterOS, contains information about the RouterOS, about the MAC address, about the board name, software ID, and so on. So again, the same way you should leave local area network interfaces and just disable interfaces from the public side. There are some router board hardware that support serial console. The console is used in cases when you for example, have accidentally made some changes and you can't access your router using the layer 2 and layer 3 level. Then serial port works independently, so you can simply connect using your PC, and it will allow you to get into the router. If your router is placed in public places, you can also disable this console, and the same goes for LCD. If you don't want to show anything, by default there's traffic. The LCD will show the current traffic, some basic router status information, and so on. If you want, you can just disable with one click. And all router board devices comes with a reset button. And this can be used when you have forgotten, for example, your password, or you made some firewall accidentally that won't let you inside your router. So you would use the reset button. But again, if the router is accessible to anyone, somebody can just come, take your router and reset all the configuration. So if you want to protect from such scenario, you can use a feature which is called protected router boot, and you can specify the time that you need to, how long you will need to hold this button till it takes some action. So only you can know this time, and in such a way you can protect your router from resetting. And firewall is responsible for protection from the layer 2 and layer 3 level, and the firewall should be used in such a way. For example, if I would want to disable all your access to some resource and just allow my PC, I would not write some tens of firewall rules to drop everybody from you, and then in the end allow my PC. No, I would just write one firewall rule that accepts the IP address from my PC, and I would write the second rule, which would drop everything else, even my PC IP, and I would still be able to use some resource, because the first rule just accepted my IP address. So this just simplifies things, and you can write less. This example will show the basic router board protection, how you can protect the router itself. To do this, you have to use firewall input chain. All the firewall is using 5 main chains, and input chain is responsible for traffic that goes directly to the router. So this means that destination IP address will be some address of the router itself, and you can protect your router with only 2 rules. First would be the rule that accept all connections with connection state established and related. This means that the connection is already seen in the RouterOS, and you would need also one drop rule, which would drop all the connections from the public side. In this case, it's Ethernet 1. And there's also additional rule which is accepting ping, but you can use it, or this is optional. So you can, because ping is considered not security threat, and you can just accept it. And there's also a forward chain, which is responsible for protecting your customers, your local area network. And to protect your LAN, you would need 3 firewall rules. One would be, again, accept rule, which would accept established related connections. We would want to drop all invalid packets, and the most important rule would be to drop everything from the public side which has connection state new. What does it mean? This means that nobody from the public side can start a new connection. We can do this only from the local area network. So if you have started requested some resource on the public side from the LAN side, you can be sure that you will receive the answer. But if you request this from public side, the packet will be dropped by the RouterOS. And another way how you can hide your local area network, you can use NAT, which is network address translation. This means that if you have multiple PCs on the local area network, then when you request some resource from the public side, normally without NAT, the packet would be sent using the source address of the PC which requested this resource. But since you can use NAT, the IP address would be changed from the PC which requested this resource to the IP address from the public interface. So anybody looking from the public interface would see that connections are coming only from the one IP address. So nobody would be able to see which PC requested this service or something. And this is the view of how firewall works. There are 5 main firewall chains. First 2 are responsible for protecting the RouterOS itself. Pre-routing, forward, and post-routing is responsible for protecting your customers. And output and post-routing chains are responsible for protecting also the routers, but it would check only the packets that are being sent from the RouterOS itself. So when the packet enters the router, it goes through each of these facilities, and the routers checks: do I need to use some action in hotspot? Do I need some raw firewall check, and so on. In cases if you want to forward the traffic from public side to your local area network, for example, if you have some server on your local area network, but you have only one public IP address which is on the router, you can do for example port forwarding. And to do so, you would need to use 2 firewall rules. One would be the destination NAT, which is responsible for changing the packet destination address. So when I would request this IP address from your router from the public side, the destination NAT would change IP address and it would be sent directly to the server. When the packet comes back without source NAT rule, this second rule, I would receive the packet from the server local area network IP address, and the connection would be simply dropped because the IP address does not match, because I requested a public IP address from the router and I received IP address from the server LAN address. So to fix, you would need to use source NAT rule. What it does, it changes back the IP address from when the server sends back connection. The router just replaces the server source address to the address I requested, and this is how I would receive this response from the same IP address I requested. So remember, if you use network address translation, use these both firewall rules. And for more advanced configuration, in cases when you want to request your public IP address, which is destinated on your router, but you do it from your local area network, there's also need to be add one additional firewall rule. So if you need to do this, just take a look at this hairpin NAT example in our wiki page. In cases when you want to block some specific traffic For example, the Facebook web page, which works in HTTPS mode. This means that you can only block this using the IP address. So that's why we made new feature that you can simply go to Firewall address list. You can add new web page. The routers will automatically resolve this DNS name to the IP address, and later you can simply use this address list in your firewall. In cases if one web page have multiple servers with multiple IP address, the routers will list all of them, and you won't need many firewall rules. You can simply use one just by specifying the address list. In cases if you want to protect your router from brute force attacks, which is made by some program or something, you can use also the firewall list, and it works like if the router sees first unsuccessful connection to the, in this example, SSH, it will add the attacker to the firewall list, which is called the SSH stage 1. If the same IP address tries to hack my router again, the routers will see it and add the same IP address to the SSH stage 2 list. And in the end, if the same host try to do it again, the routers will drop this IP address for the specified period of time, in this example 10 days. So you can be sure that nobody will be able to try more than 3 attempts to hack your router. In this case, using SSH protocol. The routers also supports bandwidth management. There are firewall fast track feature. If you remember the view of firewall chains, where each packet is inspected through all those facilities, and of course this takes the CPU resources. So if you know that the connection is completely safe, it's being established, related, started from your local area network, you can just skip all those checks and add this connection to the fast track. This means the packets won't be inspected, those facilities, and you can significantly boost the speed of your router. So you can just Google this fast track. There will be information in our wiki page. So this is a good way how you can improve your old hardware device just to reach more speed. And for limiting the traffic, you can use queues. For example, if you would like to limit this one specific IP address, you can add this to the simple queues list and just specify the upload and download speed limits. For target, you can use IP address. You can use the specify the full subnet, or just the interface name. So, and for a more advanced queue configuration, you can use PCQ, which is per connection queues. And how does it work? If you want, for example, to share all the network equally to all your guests, you can just add this rule, and you can know that each person will the traffic would be splitted equally to all your customers. And in cases when you can't understand why something is not working as expected, you can use log option. This is useful, for example, in Firewall. If you do some port forwarding or something and you don't know why the connection is not working, you can simply add option log equals yes, and every time when the packet will be received in the firewall, the routers will also write all the information in the logs. Also, you can use logging for debugging some topics. For example, you are using DHCP and something goes wrong. You don't know why. You can just add this system logging topic, DHCP, and you would, when the DHCP packet comes to the router or passes back, the routers would write all the packet information into your logs. So this gives you additional debugging options. And if needed, you can also send logs to some remote logging server. This is the view how logging looks. You can see there's for example, have been unsuccessful SSH attempt. Somebody have been tried to log into your router. And there are also some traffic debugging tools. For example, Torch. You can just specify the interface you want to check, and the routers will instantly show you all the sources and destination, what's being used for this information, how much each host is consuming the traffic, what service is being used, and so on. And for more deeper inspection, you can use Sniffer, which stores all the information which is being passed through the router. So you can catch those packets that match filter criteria, and then you can send these packets to some compatible sniffing software, for example Wireshark, and you would see all the details inside the packet. You can see all the content. You can also check the CPU resources. For example, if your the CPU is overloaded and you don't know why, you can just open profile and see what facility is eating your CPU resources. So this is a way how you can debug overload problems. You can see history graphs, and you can use network monitoring software. For example, the Dude, which is made by MikroTik. This software is completely free. Now it's built inside the routers. So the Dude allows you to monitor all your network. When installed, it will automatically scan specified networks, add devices to the live map. It can show SNMP data, it can show the routers data, it can notify you about the problems and so on. So there are a lot of features available, so you can just also check the Dude manual. And also very important is to keep your routers updated. There are three main RouterOS releases. First, there's a release candidate, which is the most recent RouterOS version, which includes all the fixes and all the latest features. There's a current version, which is tested for a long period of time. It also includes fixes, but not so much latest features. And there's a bug fix version, which is considered the most safest RouterOS version. So this version is tested for a really long time, and if you want the most trustworthy version, you have to choose the bug fix. And the RouterOS upgrade is made just with one click. You open system packages, press check for updates, and you can select the version channel, for this example the current, and just press download and install, and after the board reboots, it will be with the version installed with the specified version you choose. And in cases if something is really wrong, you don't know what is happening, maybe you accidentally disabled some all the interfaces, or just added the firewall job rules, and there's no other option. You can use the net install tool, which basically reinstalls your routers back to factory defaults. Also, the configuration will be returned. You can try to start your RouterOS from using the backup BIOS, because most of router board hardware comes with two BIOS chips. So, for example, you have there have been some problem in the BIOS update. You can use this option to wake up your router board and reinstall it. And also, of course, you can reset your device using the reset key. If your board has serial port, you can also connect using this serial interface. This is very useful for cases when there's some problem in layer 2, layer 3 access, and so the last option would be serial port. And of course, you can to debug problems, you can just for checking replace device, use some other device to connect with, just to see if the connection is good, and so on. And in cases when your, for example, CPU is overloaded, maybe it's time for upgrading device. And in cases if you are stuck in with some problem, you should you can contact consultants or distributors. You can ask help in our forum page. There are a lot of helpful users. And of course, you should take a look at our wiki page. Maybe the problem is really simple, and you can resolve it with the few configuration changes. So, in cases when the hardware where there are some hardware problems, you should also check some basic simple things like power adapter, the PoE. Maybe there's some voltage drop in the cable. You can switch the cables. Maybe one is broken. You can test with different interfaces, and of course check the power source. And you can also ask help to MikroTik support. To do so, you have to make a support file, which also can be done with a simple click, and send this file to us. We will see every step what is being taken on the RouterOS. If there's some software related issues, everything will be seen, and we will reply you and answer. And in cases when device runs out of memory, for example, there's some traffic overload or something, you have to first upgrade your device. So this means using the latest RouterOS. If the problem still remains, you should reboot your device, make one support file, and when the RAM is almost full, you create another support file, and then just send us, and we will compare both these support files, and most likely we will see what is causing this RAM overload. Maybe also this can be resolved with simple configuration changes. And when you write to support, always give very detailed explanation what is happened. Give us information how can we repeat this problem, and include as much files as you can. For example, some screenshots, also of course support files, even videos, and so on. So this will give us more information to debug the problem. So okay, thank you for listening. If you have some feature requests, suggestions, questions, just come to us. We will try to help you. And now we will have the lottery. Okay, so we have the last presentation by my colleague.